Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Akila binti Zul Ahmad Temizi. My matric number 074522. For our case study, we focuses on applying data mining technique in the education domain, specifically for predicting student performance. So for our group members, we have Yasmin, Daniel, and myself, Akila. For the data technique, we have 3 techniques, which is classification, clustering, and statistical analysis. Among the techniques we explore, classification stands out as the most suitable for predicting students' performance. In particular, models like decision tree or random forest offer strong predictive accuracy and are relatively easy to interpret. These models allow educators to identify at-risk students early and provide them with the necessary support, such as tutoring or counseling before it's getting too late. These combinations of accuracy, transparency, and practicality makes classifications the most effective approach for our educational dataset. Next, we have clustering technique, such as K-means or hierarchical clustering. Unlike classifications, clustering doesn't need labeled outcomes. Instead, it groups students based on similar behavior or academic performance. For example, it might form clusters like high achievers, average performers, and struggling students. This helps institutions design targeted support programs for each group. One of the limitations is that clustering doesn't directly tell us who will pass or fail, and selecting the right numbers or clusters or features, it can be tricky. But overall, it's a powerful tool for profiling students and creating customized learning or services. Lastly, we consider statistical analysis like correlation studies or linear regressions. This method helps us understand how different factors such as attendance or socio-economic background relate to academic outcome. One strength of statistical technique is their simplicity and transparency. Stakeholders like school boards or parents can easily interpret them. However, they rely on the assumptions of linear relationship, which may not always apply to complex student behavior. They also struggle with large or unstructured data. Still, statistical analysis is very effective for creating policies and understanding broad patterns. For example, how income level might influence graduation rate. It supports evidence-based planning in education.
Hello, my name is Daniel, and now I'll be presenting my part on the importance of pre-processing and feature selection in predicting student performance. Firstly, when it comes to pre-processing, it's important to handle missing data. Student data sets often have gaps, so missing socioeconomic or attendance info, and these type of students can affect our results. So the best thing to do is probably delete them, because if we delete them, then we can have more complete records and more valuable ones being used in the data mining model. Secondly, normalization and scaling. This ensures features like study hours and family income are comparable in magnitude. So, for example, some students, they don't study a lot, and some students, they are bookworms, they study all the time. And then you also have students whose families are earning less than 2K a month, and you have some students that are filthy rich, whose families are earning 10K and beyond a month. So what you want to do with this type of data is you want to normalize them, because if you don't, the machine learning algorithm is going to have a tough time, or spend more time actually, calculating or factoring in these data in its calculations, and this could severely mess up your model. So the best thing to do is convert these hours or the wealth in a range between 0 to 1. So the machine has an easier time factoring these data. Thirdly, encoding categorical variables. So demographic data like gender, ethnicity, parental education, all these machines cannot understand. You give it an F or M or a Chinese, Indian, or Malay, and it has no idea of understanding what these things are. The best thing to do is give them or assign them a number. So if it's F for female, you give it a 0, and then if M, you give it a 1. Or ethnicity, well, you can convert like the races into different numbers so that the machine can actually factor these in. And then finally, balancing classes. So graduate data sets can be imbalanced. Most students graduate, and if you only give the machine a data set wherein all students graduate, and you give it a mix of students who have different variables or different data, like students who study a lot and study a lot less, what ends up happening is the machine's going to think that every student by default is going to graduate, and that's a problem. If every student can graduate, then the data mining model is useless. So it's important to have the machine also learn which students don't graduate. So that's the importance of pre-processing. I'll move on to feature. Okay, when it comes to feature selection, the first thing it does is improves model accuracy. Irrelevant or redundant features like student ID add noise and reduce generalization. You do not want your data mining model to consider student ID because it has nothing to do with predicting student performance. And if you do, now it's all of a sudden going to think that BTAL 22074560 actually affects the student's ability to get a grade. And that doesn't make sense because there are a bunch of random student IDs out there and there's no way of correctly classifying those IDs into performance. And secondly, you've got reduces overfitting. So fewer features means the model is less likely to memorize noise. So you want to have a few core important features in your model. You do not want any more than that, because if you have tons of features like 10 or 20, what's going to end up happening is your machine is going to think that all of these features matter. And when you have the majority of features thinking that the student performance or indicates that the student performance is going to be good, it's going to be good, even though the key features indicates that student performance is not going to be great at all, like study hours, attendance rate, and so forth. And finally, it enhances interpretability for stakeholders. Educators and the stakeholders can better understand a model based on fewer meaningful predictors, attendance rate, and parental involvement. So if you tell other people what your data mining model is evaluating student performance on, then you're going to be able to understand the key factors that determines student performance based on the weightage of your predictors like attendance rate, study hours, parental involvement. And that's it. That's it from me. Thank you for listening. I'll pass off to my other teammates.
My name is ASSINGMENT channel, metric number 074606. To encourage stakeholders like teacher or school staff to trust and adopt our predictive model, we follow several steps. Firstly, we chose a model that's easy to understand, like a decision tree. This helps non-technical users to see how predictions are made, which builds transparency. Second, we make sure to explain the model's logic clearly, because it's important that stakeholder or user know why a student is predicted to be at risk or performing well. Third, we validate the model using real educational data through cross-validation to help ensure the model performs consistently and isn't just working on one specific dataset. Next, we present metrics like accuracy and precision so stakeholder can see that the model is actually performing well. Next, we involve educator and other stakeholders during testing and development because their feedback ensure the model align with real classroom needs or real educational needs. And finally, we make the result easy to access and interpret by providing simple dashboard or visual reports so that even non-technical user can make use of the prediction. Next, when implementing a predictive model in education, it's essential to address ethical challenges to ensure fairness and responsible use. Firstly, we must be cautious of bias and discrimination. So using sensitive attributes such as gender, race, or family background can unintentionally lead to unfair prediction. So this can affect student outcomes and reduce trust in the system. Secondly, student data privacy must be protected. Educational records like grade, attendance, and behavioral history are sensitive, like highly sensitive. So we must comply with regulations such as the General Data Protection Regulation and Family Educational Right and Privacy Act. This law emphasizes the importance of anonymizing personal data and limiting access to authorized users only. Thirdly, the model's prediction must be used ethically, so it should serve as a tool to support students, especially those who may need academic assistance, and not to label, punish, or track them in a negative way. Lastly, accountability is important. School must clearly define which staff members are responsible for interpreting and acting on the model's output. This helps avoid misuse and ensure the prediction are applied in a supportive way and structured manner.